Once upon a time, that magical phrase at the beginning of every good story. But what is the story of time? People say that time flies, that time is money. We waste time, we kill time, we try to save time. But what do we really know about time? Well, like this river, time seems to flow endlessly from one moment to the next. And the flow of time seems to always be in one direction, toward the future. But that may not be right. Discoveries over the last century have shown that much of what we think about time may be nothing more than an illusion. Contrary to everyday experience, time may not flow at all. Our past may not be gone. Our future may already exist. It turns out, time itself can speed up or slow down. And events that we think can unfold in only one direction can also unfold in reverse. But how could this be? How could we be so wrong about something so familiar? And if time isn't what we all think it is, then what is it? So, how do you begin to unlock a mystery as deep and elusive as time? Well, one way is to measure it. And using clocks of all different shapes, sizes, and kinds. But the National Institute of Standards and Technology in Colorado is the place to go if you really want to know what time it is.
This is U.S. official time. It doesn't get any more accurate than this.
Here, they measure time with mind-boggling accuracy using one of the smallest objects in the universe, an atom of a rare metal called caesium.
Atoms have a natural frequency, and anything that vibrates, that is giving you repetitive motion, can be a clock. The frequency at which the caesium atom ticks is the official timekeeper for the world.
When a caesium atom is bombarded with energy, it vibrates or ticks, giving off pulses of light over 9 billion times a second.
We count the ticks of the caesium atom, and the caesium atom ticks at this 9,192,631,770 ticks in a second. And so every time you count up to that number, 1 second has gone by. And you get 1 second after 1 second after 1 second after 1 second.
This is just astounding. My watch gains or loses a second every couple of months. We're talking about clocks that would only gain or lose a second in 100 million years.
Most people view time in a pretty simple, straightforward way. Time ticks the same for everyone, everywhere. It's a common sense picture established by the father of modern science, Isaac Newton. Sensible as Newton's picture of time may seem, Einstein realized it wasn't right. He discovered that time could run at different rates. Strange as it sounds, this means that time for me may not be the same as time for you.
Time itself is running more slowly for the person who's moving. That's amazing. No one before Einstein ever imagined that sort of thing would happen.
That was uniquely Einstein.
So why don't we ever see this in everyday life? Well, at the slow speeds we move here on Earth, motion's impact on time is so tiny, we don't experience it. But the effect is real and can be measured. To do this, all you need are a couple of atomic clocks and a jet airplane. And this experiment was carried out in 1971 when scientists flew an atomic clock around the world and then compared it to one on the ground. As Einstein predicted, the two clocks no longer agreed. They differed by only a few hundred billionths of a second. But that was very real proof of motion's effect on the passage of time.
Going to attempt time travel.
No one outside of Hollywood has made a working time machine, just yet. But surprisingly, time travel might be possible.
Now boarding Flight 24 to Black Hole Cygnus X1.
One way to travel through time is to make use of a strange feature of gravity. The familiar force that keeps our feet planted to the ground can have a profound impact on time. Hi.
See you later, sir.
Right. Much later. So, how can gravity be used to make a time machine? Well, Einstein's theories show that gravity, like motion, can affect time. It's as if gravity can pull on time, slowing its passage. And the stronger the gravitational pull, the more time slows. Here on Earth, the effect is too small to notice, but still very real. Compared to someone living on the top floor of a skyscraper, someone living on the bottom experiences time elapsing a little slower because gravity is just a tiny bit stronger closer to the ground. But if you could travel to a black hole, the effect of gravity on time would be huge. Formed when large stars collapse in on themselves, black holes have immense gravitational pull, millions and even billions of times stronger than the Earth's. And if someone watched you travel close to a black hole, they'd see time for you slow down dramatically.
You near that black hole will appear to your friend far away to be moving slowly, talking slowly, biologically, aging slowly. To them, years are passing, while for you it might be minutes.
So, depending on the black hole size and how close I get, if I spend an hour or two in orbit, something like 50 years will have passed back on Earth. I will have traveled to Earth's future.
Hello, sir.
Hi.
Long time no see. Time travel becomes you.
Thank you. Kind of like a fountain of youth. So, when I return, I'll find myself in the future. Everyone else will have aged 50 years. But me, I'll have aged only a couple of hours.
He will say, "How many years did you remain on Earth?" They will say, "We remained a day, or part of a day." But ask those who keep count. He will say, "You remained only for a little while, if you only knew." And they ask you to hasten the punishment. But God never breaks his promise. A day with your Lord is like 1,000 years of your count.